So what we're going to go over tonight is a project called Carvel, used to be called k14s, and we'll get a little bit into what that numerum means in a few minutes. But really, it's a set of standalone tools that, to me, really encapsulate the concept of the Unix philosophy, which is do one thing and do it well. We don't realize it, but every day we're reaping the benefits of, I guess, depending on where you start counting, anywhere from 30 to 40 plus years of software development. If you're logging into Bash or Z Shell, if you're one of the newcomers, one of the hipsters, we're using ls, we're using mkdir, we're using gzip, and like those things just do one thing. And the beauty and the magic of having this collection of tools that only do one thing is it gives you this incredible flexibility to build out a pipeline, to build out a capability that suits your specific needs. You don't find yourself having to bend over backwards to accommodate this oddball behavior that can be squelched with this one flag that only 3 people know about. Instead of you having to accommodate the tool accommodates what you need. So let's get into that. What are we going to go over in this talk? We'll answer the mail for why more tools. Kubernetes is complex enough. Why are you showing us more tools? I'll show you why in just a minute. We'll go over the typical app deployment lifecycle, from how can I deploy my application into Kubernetes, and then we'll move on to solving the challenge of how can I customize the configs. Because like we're all pretty familiar with the concept of templating, but what's interesting to me here is this new concept to me called patching. We use overlays that come with one of the tools in the Carvel toolset. It's like if when the original authors of, say, a Helm chart didn't expose something and you need to add that ability in there, this is where patching helps to cover some of that. The next thing we'll cover is container building. There's a million ways to do it. We'll show you one way that works pretty well and goes into a lot of like write, build, deploy, test cycles to help speed up that iteration cycle, so you're not spending all your time mired in Docker build and Docker push commands. And with the little time that we have left at the end, I'll show y'all what I'm starting to call app deployment as code. I'm sure that's the completely wrong term to be using, but it's a pretty cool way to codify multiple sets of applications and to have like one command to deploy them all into a K14s cluster. And as always, feel free. This is a guided discussion. If something comes up, like if there's a question or if I misspeak or if you just want to heckle me, feel free to unmute and say something, or just drop it in the chat and we'll be sure it gets the attention it needs. So why more tooling? So deploying code is hard. When I first got my Kubernetes cluster, I got kube control and I had my Docker file and I had my source code, and I was like, awesome, let me get this thing on here. How do I upload my container to Kubernetes? Like, where's my kube control push? How do I get that? And everyone was like, whoa, that's not how it works. You gotta push it to a repo first. Then you gotta write up some YAML files that tell Kubernetes where that repo is and that you need to pull it down. So immediately it's like, well, now I gotta do all that. Now I gotta build it. Now I gotta push it, and I gotta figure out what this manifest file looks like. So like, how can I do that quickly? And that's just at the local level, right? If we're talking about getting away from like the personal side project or just my little feature branch, deploying code into prod is even harder. So now if we have all of these CI checks, we need to inspect the code. We have to run security scans on it. We have to then containerize it. How are we going to containerize our application? And the whole thing, like, to say that we're going to build a CI/CD pipeline is easy to say, but it can be a real challenge if you're trying to manage this like huge portfolio of applications. You need a set of tools that are going to help you like answer the mail for, how do I know that each of the apps are secure? How do I know that I can keep my CI/CD pipeline flexible? How do I make sure I don't like trap myself into a framework? And there's a way to that. It really is in this. Keep it simple. That includes the tooling that we choose to use. So enter Carvel. So you may have heard of a tool set called k14s previously. And the quick lesson in numeronyms that I promised a few minutes ago was we all call Kubernetes Kates. And if you want to impress your friends next time you're at the bar after we're all vaccinated, is we call it Kates because Kubernetes, in between the K and the S, there are 8 letters in between. So we're lazy. We don't want to type the whole thing out. We call it K8s. So that's how we got Kates. So if we take the same concept and we say Kubernetes tools and we apply that same algorithm, we get out k14s. So now you've got 2 ways to impress friends next time you're out for a drink. Ultimately, some branding got around that, and it became what's called just the Carvel toolset. So this thing provides a set of reliable, single-purpose, composable tooling. And I've already gone over like why that matters earlier with being able to put together your own flexible pipelines. So let's jump straight to the first tool in the set. This one caveat, what we're talking about here today is only a sampling of the tool set. We don't have the time to cover everything in here. I just want to cover what I think are the sort of like top 3 or 4 most applicable. So as you start off on a Kubernetes journey, we're going to say, how am I going to deploy my application? And the first thing you're going to do is write your manifest file. Here is my pod. Here are the container images I need you to put in that. Kube control apply, and Bob's your uncle, I got an app on Kubernetes. Awesome, thumbs up. As you progress down that journey, what you'll find is you want to start deploying more complex apps. So can I pull in a database? I need to have a persistent volume. How can I expose this via a service and get a load balancer to expose my application? Or even get two load balancers, keep one internal so I can access some other things. Like when things start to get more complex, that's where, say, a Helm chart comes in. So that your Helm charts are going to be your overarching sort of container for what your deployment looks like. And Helm charts are fabulous. We should continue using them. But a couple of challenges that I want to point out is how trackable is that when we're using Helm charts, and how can I go about customizing these things when I'm consuming them? More on that customization part in a little bit. So enter CAP, short for Kubernetes application. So at first blush, this is going to look like the same thing. It's pods, it's services, etc., and it's all under one overarching umbrella, logical container bucket. One difference that I want to point out is this is a yes and kind of situation. I'm not here to tell you that CAP is a replacement for Helm charts. It is not. CAP is here to help you reliably and predictably deploy applications into Kubernetes. One of the things that can be part of your app as described to CAP is a Helm chart. And in fact, that's one of the more common flows that we see is you basically run a Helm command that just basically dumps out that Helm chart, and you run it through a couple of templating pipelines, and ultimately that final output is what gets passed over to the CAP command. So let's see, am I getting a little bit there. So no good tech talk is complete without a couple of demos. So we're going to get to what this looks like for using CAP for deploying your applications. Make this a little bit bigger. So what we're looking at here is it's a simple Go app, and we've got a couple of directories that are going to walk us through the deployment lifecycle. So what does it look like when we use CAP to deploy our application? So what's happening here is we're starting off with the CAP command, and I'm going to say CAP deploy. -A is just app name, so I'm going to call my app a simple app, and the -f flag we can use as many times as we need. It can be specific to a single text file, or it can be a directory full of files. So we're pointing it to that directory. Let's see what's in that directory. So right now, all we have that we're going to deploy is this super simple Kubernetes workload. We've got this service that's going to expose our application, and then we've got our deployment. And we tell it where that container image is going to come from. So yes, we can do a kubectl apply -f and pass it over to that. But all that's going to do is just create a smattering of pods in our cluster, and it's going to be difficult to track where those pods are, and it makes it hard to find that. So what I can do here is I can say cap list. So right now, boilerplate stuff. This guy is cap controller. This guy is one of the default workloads in my k14s cluster. So my simple app is not out there yet. So we're going to run our command deploy-a simple app, passing it in that one config that we just looked at. So it's going to read that config file, and it's going to query the k14s cluster, and it's going to come up with a reconciliation. So it's going to say, okay, I got you. Here's what I'm going to do. I'm going to create two things. And because this app never existed before, nothing else is going to happen. No deletions, no updates, etc. So we're going to create a Kubernetes deployment. That's what we saw in that manifest file. And we'll create a Kubernetes service, the same exact one that came from that manifest file. Let's go ahead and give this guy the thumbs up. So we get to see here in real time, like, we're done. That deployment's done. So it's in more complex applications, this takes a little bit longer than a second and a half. But from there, you can see it's applying the changes. So it says, I'm going to create a deployment and I'm going to create a service. And they all happened rather quickly from each other. In fact, they happened like at the same time. I think we'll be able to see a little bit later when it has to actually wait for a few things to reconcile. So what I can do now is I asked for that service. So that gets me the FQDN for the ELB that I got. So when we create a service in Kubernetes, I asked for a type load balancer. There's multiple types of services. One of the more popular types is load balancer. So if you create a load balancer service in your Kubernetes cluster, if you're in Amazon, it's going to create an ELB for you, and it's going to terminate that ELB at that pod that you wired up to your service. So DNS usually takes a little bit of time. I was trying to run out the clock and let the DNS update for that. Let's see if it took. Let's do a little browser on here, paste that in. Cool. So that worked. So super simple, just comes out and says, gives us a nice little greeting. I'll pause. Any questions on cap deploying or what cap means, or like, is this something, is this like a meaningful thing to y'all?
To me,
I mean, silence is fine too.
No. To me, it is. It's very important to show coordination of your deployments, first off. And that's what Helm charts was giving you. And therefore, you need some way of tracking these things. And I think it's very important to have these things, but trackable and checking in code. But now we're checking in possible configurations that I hope you're going to be even talking about with Kappa.
Exactly. Yes, thanks for that. And I believe you understand, Peter, but it's worth repeating. Like, you can use Helm charts as part of a cap deployment. It's a totally acceptable and in fact common pattern when using it. And I don't know that I have quite that for this demo here, but it should be pretty easy to fill in the blank here with that. But yeah, to your point, I fired off a cap list command, and there we go. There's my app right there. And what's really fun now is we can believe.
So if you were in a very noisy place, a noisy cluster, okay, would cap app limit your view of what you just gave as a command?
A noisy cluster. So do you mean to say, like, if there was a lot of stuff, would my single app get lost in the noise?
Yes.
Really, that's kind of a function of the operator. I mean, there's also, I'm nearly certain you can also scope it down. I think it by default will hit the default namespace, but you can pass it the appropriate flags to say, like, look at all the namespaces, or look only in this one namespace. So there's ways of scoping it down for simplicity.
That's fine. That's fine. It's not really its purpose.
Fair. Yeah. So I just fired this inspect command, and now, like, all I asked for was that deployment and that service. But when you do that, multiple Kubernetes objects get created as a consequence of that. And CAP is able to track those things as well. So while I, in using CAP, didn't explicitly ask like to have an endpoint created, that is a consequence of creating a service. And CAP's aware of that, and it's able to track all of those various objects that get created to support the app that you go to deploy. So what we'll go on with next, with the deployment having been solved, is customizing. So there's two approaches, and it's not an and or, it's a yes and kind of thing. Just like you can consume Helm charts as a part of a CAP deploy, you can implement both templating and patching in your deployments. So a quick visualization. What am I talking about with templating? If you've written any sort of YAML that had curly braces or had some $signs or anything else, like, you're familiar with templating. So what we're talking about here is on the left-hand side is I've just got an example load balancer. And you can see these annotations here, this sort of #@ here. That's the that's what YTT, which is the next tool that we're talking about, a YAML templater, because we like being ironic when naming our tools, is you'll see here the port is going to be assigned to the value for data.values.service port. And I'm supplying those over in my values file. So I'm telling it service port needs to be 80, the app port needs to be 80. And then this is a poor example because there is no hello message on the left-hand side, but it's effectively, here's my bank of values. Here's the template that I want you to use. Mash them together and create an appropriate template for me. So what templating looks like down here with this Carvel toolset, let me clear the screen here. So in this next stage, I've got my config, but I've also got this values file. So over here, we've made some slight updates to our config. Most notably is what we looked at just a second ago, that port and target port. But then down here, what I want to call your attention to is this environment variable. So our little Go app gets its message through an environment variable, and that environment variable is called hello message. So what we're going to do here is this has been templated. So we're going to pass in the value that way. And over here in this file, I've said, I want that value to be somebody. So the net of this, when I redeploy this, it's going to be called hello somebody. We'll quit out of that. The beauty of copy paste is it works. The challenge with copy paste is sometimes it takes time to highlight the appropriate words. So let's walk through what this little incant here is. So I'm starting off with YTT. Just like with CAP, I'm passing it that -f flag and I'm telling it, look inside everything in this directory here, which is what we just looked at right there. Now you've got two options. I can override that value. So in that values.yaml, I assigned the value that I want. You also have an option to pass it on the command line as well. So again, flexibility, whatever works for you. I want to show that what's in that file is showing up. So I'm going to go ahead and clobber this flag. So the output of this YTT command is just YAML. It's taking the values and it's templating, it's rendering them through the config YAML file and dumping it out to standard out. So we're going to take that output and pipe it over to our cap command. And now what we're doing here is these last couple of flags, this -c is for confirm. We're passing cap the -f flag again, so it knows where to get its configs from. And the value for -f is just dash, which means take it from standard input. And because we don't want to be clobbered with our pipeline failing because we have this user prompt, we're passing it the --yes command to say, just go forth. So we're using YTT to template the YAML and we're passing that over to cap deploy. And I am in the wrong directory. So it didn't prompt me because of that flag, but we get a diff right here. We're changing that value out. We're swapping out stranger for somebody. So it went ahead and did that update. Let's drag this thing over here. So if we bring this thing over, so where it says stranger, we should see a somebody. We'll hit refresh, and we've changed that out. So you can see how we have this like quick iteration here with this patching. Let's go on to the next step here. So this is cool. We can template things. What if there aren't enough nerd knobs though? Like as an example, the that config that we have that we've been using, my deployment, it just says a deployment. So if I don't specify the number of pods, I'm only going to get one pod. You know, this is a bit of a trivial example because adding in like a number of replicas into a config isn't that difficult. But the point here is you can take an upstream artifact like a manifest YAML file or like an entire Helm chart, and you can insert your own patch configs into there. So what does this look like? Is over on the, again, on the left-hand side is our upstream artifact, which is just the deployment config that we've got. And you'll notice what is absent from this is the replicas key. So we just have a selector and with the match labels, but there's like no amount of templating is going to fix this. I have to go in and modify my config file, which is fine if I wrote my manifest file, but if I'm consuming an upstream Helm chart and I want to make a change to that Helm chart, now I've basically forked that Helm chart. Now I have to keep up with all of my changes that I'm keeping locally. I'm effectively frozen at that version I have. I've turned my deployment into another software project that I have to keep up with. The alternative to that is we can patch that in. So we take this, there's a language around how to intelligently scope down and match exactly where you want your additional configs to go. But for this simple example, we're just telling it, look for anything that is of kind deployment. So we're telling YTT, look for any deployments and look here. If you see a spec for the deployment, drop in the key replicas. And for simplicity, assign a value of 3. So we'll switch back down here and show what that looks like. Here we are, overlays. So this is the overlay file. Bunch of YAML, bunch of boilerplate, but really the important part is we're going to tell it when you see that spec, drop in that replicas 3. Back out of here, let me find that command. So this can go both ways. My mistake, sorry. So anyway, we have our cap deploy, and we're using the same flag again here with that -f, and we're going to feed it the output of our YTT command. So again, we're saying YTT template, passing it -f, and we're telling it everything that's in that step 2 that we were looking at. In addition to that overlay that we just showed us. And the last thing is we're going to go ahead and put in an inline flag to upgrade that message to go from stranger to somebody. We're going to change it to friend. So 2 things are going to happen. We're changing out that environment variable, and we're going to increase our number of pods. One thing I want to show real quick. So I did the cap list, but if we do our kcontrol get pods, we can see here's our simple app. It's a single pod that's running. So we go ahead and run this deploy. So we're sitting here polling, waiting for everything to scale up. And we can see waiting on that replica set. So it's scaling it up for us. So if I run that kcontrol get pods again, we can see that it's still in the process of terminating the old ones. So we've scaled that up from 1 to 3. And additionally, if we slide this over again and hit that refresh, we've been upgraded to friends. So there's a lot to talk about here. I don't want to go into like all of the details and intricacies, but there's a lot of power here in the scoping language, the templating language that's available in YTT. And like this is where you can come up with some really powerful incants as part of your pipelines using Jenkins, using GitLab, and whatever works. These can be your core sort of commands to orchestrate this activity. A quick comment. I had mentioned that we want to avoid making forks of Helm charts and making modifications and forcing them in and adding those in. What we also want to avoid is building up a lot of patch cruft. So if you're consuming a Helm chart and you find that there are some configs that you need to put in there, you're probably not alone. Please do consider filing an upstream fix. So go ahead, follow the project's rules, fork it, make the change, commit it upstream. So that way, when you are now the downstream recipient of that change, you can remove your patch. This prevents this sort of cruft building up and having to wonder, like navigate all of these various things, because it's very easy to paint yourself in a corner if you're not cognizant, if you're not aware of how you're using them. Okay, container building. Before container building, I'll pause for a couple seconds. Any questions around templating or patching in general?
Hey, Drew.
Yes, sir.
Do you know if the templating language that YTT is using is something like apart from that tool, or is it something custom that they made for that tool?
That's a good question that I don't have a solid answer for. It is like, it's a standalone binary, so all the logic is inside just that one binary. So they're not farming it out to anything. That being said, it might be a specific, I hesitate to say language, but a specific sort of language for that. Like the real question is, does that apply to like any other tooling, right?
Right.
And I actually don't know that. My first guess is it's probably going to be specific to it. I know that like myself as a SaltStack fan, I immediately notice it's not using the double curlies. I think that's used in Ansible as well. But I want to say it's specific to that tool set.
Gotcha. Thank you.
Yeah.
So
now I gotta look it up later.
Here's another question that if you have time for it.
Absolutely.
So when you see these things and everything sort of means, there's a lot of flexibility and a lot of power here, okay? You're showing a lot of great things. But my concern now goes into the fact like, okay, it's a simple statement of flexibility breeds complexity. How would you, or are there any thoughts as to how you would test this going forward to ensure that what you're kicking out is what is intended?
I want to go a little bit more on what you're kicking out is what's intended. That sounds really important. Could you rephrase that?
Yes, okay. As an example, when I've done this inside of JEE servers, as an example, you would write something called Jython. Jython would allow you to manipulate the server and manipulate all the configurations within the server. As of one of the most important things that we would do is we would blow away anything that we were going to change. We would blow it away. We would delete it, remove it, and get it done so that there's no way that we would not be able to update, and therefore the order of creation mattered to us. Jindies had to be created first, and then you could actually then deploy the ear as an example because they had dependencies. So with these types of thoughts that you're putting into this, the way we would test it is, okay, we got a green light, the ear started. We got a green light that the URL responded. We did, other testings on the UI to make sure that the pages actually showed up. And this was all automated. Therefore, we had the intention that everything was there. And it was just a full-blown system to ensure that the differences that we were kicking out were intended. Just like you've shown manually like we saw friends. But you're not seeing what we're like counting how many pods are running or how many things are there. And you're not kind of like showing some of the things that I'm more concerned about, like all the network restrictions that I want to actually put in place to now not allow like pod or container A not being able to talk to container B and only being able to talk to container C.
Gotcha. A lot of that is, I mean, being honest, the number one way to be sure that what you're making is what you want to be making is going to be discipline, frankly. It's going to be discipline on the team, but there are patterns and tooling to sort of take the edge off of that level of rigor that's needed. I'm actually glad you asked about the, like, putting in network policies, putting in like ingress controllers. That actually tees up really well what I want to touch on after the container build part, which is like, how can I have that confidence that in this case, my K14s cluster has all of the appropriate controls on it. Like if I'm putting in logging, monitoring, metrics and auditing, all of those workloads, like how can I be sure that that stuff is getting in there? I'm one of the models that I've started looking into and I'm kind of a fan of is I'm loosely calling it the the GitOps model. Like everything that we've looked at here, you can use a Git repo as your source of truth so that if you need to know like what is it that I'm actually deploying, you can go and look in that location in your Git repo to have that level of confidence. And also like that same sort of reporting and metrics and et cetera can also help with giving you that level of assurance that what's out there is what you intend to put in there. I feel like that was kind of a roundabout answer, but does that kind of scratch at it a little bit, Peter?
It scratches a little, but right now I'm working on another thought because another company came to me and said, okay, it's not enough. I don't care. It's not enough. And now when we're creating containers, I don't care who the operator is. I'm now putting in my own OAuth container. It's going to have OpenID on it. It's going to have JWT on it. And by God, everybody has to talk to this thing. And when I get done having everybody talk to this thing, I want something else to lock down all the stuff. And this is now we're going to sway into like the idea of ISTO and Envoy and all these things. So they want 3 things included into this that is not just say, I don't care how many pods come up. They're saying, I want it all locked down. And then I want you to have something that is like a snoop to stick in there to show me it's all there.
But what you're talking about is like infrastructure framework and development tooling that all chains together to become a cohesive platform, right? So like what we're talking about here is one tiny piece of something that you could use inside of a framework like that.
Yeah, no, I understand, but I'm just trying to sway into where, I don't know where Drew's going right now, but this is really great stuff and it's highly flexible, but it's to me, it's going to be hard to test it without deploying it.
Yeah, that's fair. I want to get your feedback, Peter, once we're done with once we get to not the image building part, but the part after that. I want to hear your thoughts on that to see if that helps with like that greater ecosystem. So we'll get into this part next. Container image building. Let me click on this and it'll come back up here. So backing up a little bit and getting like back to the local iterative cycle. So like every time that I write my code, every time I want to deploy it and I want to observe it, multiple things have to happen. I have to build my container. I have to push it to a repo. I have to tell Kubernetes to go ahead and deploy my app. So in absence of an entire pipeline that the DevOps team built out for me, how can I just starting out get a quick iteration cycle going to where I'm not constantly shelling out and running Docker build, Docker push, and like putting all these things together. And the last thing to note before getting into the details here is something that can happen, especially even if we're using tags to describe our container images. The default behavior of a K14s cluster is it's going to use a cache of a container image. So if you tell it like use my code version 5 and you've made changes and you've pushed that new code up to your repo, if that tag is still the same, the k14s cluster is just going to say, well, I've already got this container with this tag. I'm just going to use that. And you're going to wind up pulling your hair out because you're trying to test out your new code. You don't know why it's taking. And what you can miss is the cluster hasn't even pulled down your new code. And yes, this can be fixed with some extra knowledge, like changing the image pull policy on your application. That is one avenue. But this flow that I'll show you also guarantees a way that the new code that you built is going to get run. So enter kbuild, Kubernetes build. Just does one thing, builds container images. So supports both Docker files and cloud native build packs if that's your jam. Fits into any workflow, like we pointed out, flexible just like anything else. And gives you that sort of rapid feedback loop. So what this looks like here, so let's come down here. So this is going to be my instructions that are going to be passed over to kbuild. So 2 useful things to know: sources, where am I going to start with, and then destinations, where is it going to go? So it's going to start with this app, and then we have we're using our templating again, and we're telling it dig into this data value for where it's going to get pushed to. So I've configured this to go over to my image repo that I've set up. So I should already be authenticated to that. Find that command. So just like all of the other commands that we've seen, we're going to start that off with a cap deploy and feed it the output. We're giving this the templating that we're familiar with already. And all of those details, so the templating, you'll notice we're digging into that config step 4. So we're passing YTT all of these files that we were just looking at, instructing it like where it's going to find its container image and where it's going to push it over to. Now, the one thing that I do need to showcase before doing this someone hit me with their favorite beer or dessert.
Brownie.
Thank you. So we're going to make a local change here and feed that into our command. So it's pulling in, there's a Docker file here, and it's using that Docker file to build the container for us, which allows it to pull in that code change that we have here. So I had mentioned that it guarantees that the version of code that we built is what's going to get deployed. This is because kbuild is outputting a digest for our container image. So what's the difference between a tag and a digest? A tag tags are useful. We should continue using them. They can be stuck onto a specific version of a container. But the thing about tags is I can come into my repo and I can take my tag, pick it up, and I can apply my tag to a different version of my code. This means that if I'm saying I need to deploy the tagged version of a container image, me as down here as a developer deploying my code, if I'm asking for a tag, there is a possibility that I could be deploying a different version of the code than what I think I'm getting. As opposed to digests, it's literally a SHA-256 sum of the container image itself. So it's guaranteed to be unique. This is the output that's getting fed to that cap command in the manifest file that gets dynamically generated for us. So this is what guarantees us that you will get the version of your code that you asked for deployed to your cluster. So what we want to do here is show that we've swapped out our friends. Well, not swapped out. We keep our friends, but we also bring in brownies. So that local change that I made on my workstation, I pulled down the code, I made changes, automatically built that container image, and in one command, built the image, pushed it to the repo, applied a digest to it so I know it's unique, and gave that command to my cap command, which caused our updated application to get rolled out. Any questions on that? On building applications on like this sort of streamlined method for this quick iteration cycle?
Sir, I'm trying to wrap my head around this. So the command that you just ran,
Yes.
you're chaining together a few tools there, right? So YTT is templating everything in that folder. That has both your deployment and some configuration discussing how it's going to build a container for you as well. So basically, YTT is templating all of that stuff together.
Yes.
So pass it off to kbuild, and it actually builds the container, pushes it to the repo. It then passes out of that output file that you're creating into cap, which is then deploying the stuff. So the config at that point is passing out of that pipe, and cap stores it in Kubernetes.
Cap uses it as input. So this is a good question. Appreciate you calling me out on this. Let's decompose this like 3-stage pipeline. So here's just the YTT command. The output of that command is this manifest file. So really all it's done is fill in the blanks for the templating. So down here, this environment variable now says friend. It's not a call out to some ambiguous data structure. So that's the template part. Another part that I want to call attention to is this config here. So this block of the output is germane to kbuild. So these are instructions for kbuild. Grab the image from here, work with it locally, push it up to my container repo. So kbuild, what I'll do next is I'm going to run this command now, but again, I'll pipe it to kbuild, and we're going to look at the output of that next step. Kbuild is going to read in these details, and it's going to spit out a different looking version of this deployment here. So right now, it's saying, the deployment says, pull my container image from docker.io/this repo. When we run this again and we pipe it over to kbuild, kbuild is going to replace that with the output from where I told it I need it to deploy. Clear the screen here, reduce the noise a little bit. I'm going to remove that cap deploy. So the output that we're going to see here will be the information that gets passed to cap deploy. So I got to use a lot of caching here. So it rebuilt my, my application. So now what I'll call attention to is, here is our deployment manifest. And then down here, here's the container spec. So we still have the environment variable here, but this image has now been changed. Instead of coming from the original place over on Docker Hub, where the instructions now tell it to pull from is the container registry that I told kbuild to push it to. And it's gone so far as to specify the digest that it should get pulled down. If something that I could do, I could copy and paste all of this YAML into a YAML file, and I can say cap deploy -f my YAML file. I'm just doing a lot of sleight of hand by using this bash redirection and just feeding it to cap via standard in instead of feeding it through a text file.
Gotcha. And so I can't see the whole screen. Those configs, they're stripped out at this point. Like the kind config that was dumped into kbuild, does it survive that? Okay,
it does not, because that the kbuild details were only relevant to kbuild, so they are not in the output of that.
Yeah, I was just trying to gauge, like, you know, these tools seem to be built to be standalone, and I just wanted to make sure that, you know, like the output of this should be deployable by like anything, right? Like you just deploy it with kubecontrol if you wanted to.
Correct. I can do this with a kubectl apply -f. Yes.
Cool.
Yeah, appreciate you asking that question. It's easy to kind of gloss over this, but there is a lot going on under the hood. So we'll come back up here. Okay, real quick, I don't want to push us too far past the 1 hour mark. So we were talking earlier about like, I need to have like, I'm building a platform. I need to put in logging. I need to put in monitoring. I need to put in metrics. And like, we can do that in pipelines with having like kubectl apply -f, like my entire directory full of manifest files. But a bigger, this sort of emerging pattern is what I'd like to call is using your Git repo as the source of truth. So this little guy is something called cap controller. And using this visual, it's a small workload that lives inside your Kubernetes cluster. You configure it, you tell it what jurisdiction it has. Like it can control only these namespaces, or it can control like some number of namespaces. And what you do is you configure it to point to a particular Git repo, and then you put your manifest files in that Git repo. And what's going to happen is cap controller is going to pull those Git repos on a regular basis. And it's going to, whatever it finds in those Git repos, it's going to run through its reconciliation process, and it's going to deploy those manifest files. So the consequence of this is you put a small workload into your K14s cluster, and now the way that you deploy new workloads or the way that you update your workloads is no longer with like a kubectl apply or even a cap apply. You just do a git push to your Git repo, and cap controller is going to pick up on those changes, and it's going to deploy those workloads down there. So you can imagine like if you're running multiple Kubernetes clusters and you need to be sure that they all have like a baseline of applications installed, that all you have to do is put one workload in there with the appropriate configs. And now all of your Kubernetes clusters have that sort of baseline workload in them with auditing and logging and metrics. And not only that, but when it's time to update that workload, all you have to do is make a one change to your Git repo, and the clusters are going to start updating themselves. So now we're not even talking about like iterating through our clusters or having to come up with some clever shell scripts to change out our kube contexts. Like this is all just going to happen in parallel. Worth pointing out that you do need, I would strongly encourage caution when doing this. Definitely have a sandbox environment. Definitely test out your upgrade paths, because there's no confirm switch in cap controller. It will just apply what it sees, and the outcome can be amazing if it does what you want it to do. But you can imagine this being somewhat disastrous if we're not positive that the changes are going to work out. So kind of running up on time, I'm going to go ahead and just open the floor for questions, etc. We've seen really the way cap controller works is highly similar to the way that the cap experience works. You can track it, you can inspect apps, and you can wire in your different applications that you have to deploy. So hopefully this is useful to y'all. Apologies if it was kind of a little bit too glossy, too brisk going over those details. But really the takeaway is small set of utilities, open source tool set that takes that Unix philosophy, applies it to the complex world of Kubernetes, that hopefully can help you put together some good pipelines and some good work cycles. Yes, on that quote, yeah, thank you, John. With great power does come great responsibility with that cap controller idea. With that, I'll go ahead and open up the floor. Comments, questions, or anything else that we didn't cover in here. I'll go ahead and count to 10. If you've got something to, if you're feeling shy, go ahead and put it in the chat. Otherwise, feel free to unmute.
I just have like really broad questions, I guess. Like, how deep have you gotten into this? Like, have you put it into any like CI/CD pipelines in order to do fancy things? Like, is that the intent here? Is like, hey, I'm gonna run this in my pipelines to do awesome stuff in my build process or whatever, because so you could certainly use it from your laptop like you've shown, but I think there's going to be a lot of power in tying it into a bigger framework.
Agreed. And I have not personally, but I have teammates that are using it in pipelines. So like, the act of building a container or the act of taking a bunch of YAML files with templating, applying a values file to that, and then taking the resulting YAML and then handing that over to like a cap command in one command that's in a pipeline. I do have teammates that are using that to deploy applications, and like not just applications, but they're also using that like to package up the deployment of I don't want to say like products, but like workloads, like deploying ingress controllers or deploying other like the workloads that turn a K8s cluster into a platform. They're using this way of applying. So instead of the instruction manual saying "control apply -f," the instruction manual, the install docs will say like cap deploy -a, and then it's a pipeline that pulls in all the appropriate YAML files. To be fair, or to be clear, it is a still in its early stages. The entire tool set, definitely not as old as the bedrock Unix tooling. So there will be edge cases, there will be nuances as it matures, and even still, the models and the ways of using it are still an emerging pattern. So it's definitely something to keep an eye on. I would say try it out, see if it works. And if it does, it's awesome. If it doesn't, I actually kind of want to hear about it. I'm curious to see like where the room for growth is in something like this.
Yeah. So you mentioned it's pretty early on, especially with cap. I like it. I'm kind of an Argo hater because it's got an awful UI, but cap doesn't have a UI yet, which may be why I like it. It doesn't have an opportunity to disappoint me. So I guess my question being like on the CD portion, right? Like the deployment portion, um, probably Argo and Flux and maybe some other players are already in the space and probably a little bit more mature. How much heat do you see around cap and sort of a push forward in the community to use it?
I think it's still in its early stages, and I see it as playing alongside the existing playing field. Like this is definitely not a thing that's going to supplant something like Argo, something like GitLab or Jenkins. To me, this is like when you're putting together your jobs in Jenkins or you're putting together your pipelines in like GitLab CI, you're frequently going to shell out to run some commands. And this is where I see that tool set living. So really, in my mind, it plays well with others. If you have the opportunity to shell out to do a few things out on the command line, that's where you're going to reach for something like this. I don't feel like that fully answered the question though. Did that address it?
Yeah. I got one really quick one and then I'll yield the floor. So I was looking at the Carvel website, and there's at least one, maybe a couple tools in the suite that you didn't mention tonight. The one that I had the hardest time wrapping my head around what a use case would look like for it was Vendor. Have you looked at that?
I know the name, but I'm tragically not super familiar. What's the slick sheet say?
I mean, the the thing that jumps to mind is it's almost like a command line tool that performs. So,
Mm-hmm.
You basically define what a directory structure is going to look like, and then it could be multiple Git repositories or other locations, and it pulls all that information in for you in order to, create a directory structure. And I suspect that it's used in some build pipelines or something, and for libraries maybe, but I was trying to figure out if there was any like use cases that I could look at for it.
Oh, vendor. That's a really good question. Sync any number of data sources into a consistent structure by writing a YAML definition. Share that generated file. Yeah, I see this as more of like, we were talking through all the pipelines, and like the currency of the Carvel tools is like the config.yaml, the values.yaml. Where I see this is like stepping up one level and being able to declaratively say what needs to belong in those directories. So I see this more of like, I need to package a complex workload, and I'm going to use this as part of the way that I package my workload.
Gotcha.
Any other questions or thoughts or comments for the room?
Hey, Drew, thanks for the presentation. Quick question. Am I to understand, like, as long as you have kubeconfig set up, cap should just work?
Yes, all of these tools use the exact same kubeconfig that kubecontrol uses.
Okay, thanks.
All right, I'll give it another count to 10 before we call it for the evening. All right, let me break
Thank you,
out of
Drew.
this
Thank you,
screen share.
Drew. Thank you. Thank you.
Thank you, Peter. Thanks, y'all.